Today we are talking about section 9, which is the very last section in chapter 6. And it's been a long section, there's been a lot going on here. We've been building a lot of things, but we are finally to the culmination of where we are going to be able to solve very accurately and efficiently any polynomial equation that's going to be thrown our way. So we're going to be looking today at what we call the rational root theorem. And this rational root theorem, like I said the other day, is going to really allow us to know exactly which roots or which zeros we should test and which ones we should avoid. Should we go with positive? Should we go with negative? All of those different types of things. So go ahead and copy down this theorem, which is the rational root or the rational zero theorem, which just says let f of x represent a polynomial function with integral coefficients, and that just means they're whole numbers, no fractions, no decimals. If p divided by q, or p over q, is a rational number in simplest form, remember, a rational number is just any fraction, could be a whole number, and is a 0 of y equals f of x, then p is a factor of a naught, and q is a factor of a sub n. Remember, a naught is the constant term at the very end. So the numerator is going to be all the factors of the constant, and the q, which is the denominator, is going to be all the factors of the leading coefficient. So let's take a look at what that means. So if we want to look at all the possible rational zeros of each function, what we're looking at is p over q, where p are all of the factors of 9. So what are the factors of 9? That would be a plus or minus a 1, a plus or minus 3, and a plus or minus 9. Because 1, 3, and 9 are all factors of 9. Then the denominator is all the factors of the leading coefficient. So this is where the q comes from, and this is where p comes from. And so that would be plus or minus 1, plus or minus 2, because it could be positive or negative. Now, that's kind of how we create it, but to technically give us the answers, we pair every numerator with every denominator. So I'd have 1 over 1, which is just plus or minus 1, 1 over 2, which is plus or minus 1/2. Then I have 3 over 1, so that's plus or minus 3, or 3 over 2, so that's plus or minus 3/2. Then we have 9 over 1, so that's plus or minus 9, and then 9 over 2, plus or minus 9/2. Those are my possible rational zeros. So if you found out there are no negatives, you would just have positive 1, 1/2, 3, 3/2, 9, and 9/2. If you found out there's no positives, you'd have negative 1, negative 1/2, negative 3, negative 3/2, negative 9, and negative 9/2. But if there's at least one of each, then you have to try all of those until you find a 0. You don't have to try all of them, but try all of them until you find a 0. So let's go ahead and take a look at this next one. Again, p over q. All we're looking at are the factors of this, of the constant. So what are the factors of 105? We have plus or minus 1, plus or minus 5. We also have 3. We have, so let's see, it's going to be 1 and 105. It's going to be 5 and 21. And it's going to be 3 and 35. And then I believe it should also be 7. Yeah, it should be 7 and 15. So plus or minus 7, plus or minus 15. So you don't have to put them in order, just as you come to them. So like 1 times 105, 5 times 21, 3 times 35, 7 and 15. Those are all factors of it. Now in the denominator, it's the leading coefficient, whoops, not PQ, which is just 1. So there are no fractions, it's just all of those numbers. So we have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7. Then we go to plus or minus 15, Then we have plus or minus 21, plus or minus 35, plus or minus 105. And those are all the possible rational zeros. Alright, the next two examples. We're just going to go through the entire process from start to finish of how do we go through and solve for all of the zeros. So we're just going to start at the top and we're going to incorporate everything that we've done, pretty much everything we've done in this entire chapter is what's going to happen here. So we start by looking at our sign changes and finding out how many positives, how many negatives, and how many imaginaries do I have. Then we'll go into what are our possible rational zeros. So step 1 would be how many of each. Step 2 would be what are my possible ones. And then step 3 would be testing those and actually doing synthetic division. So let's go through and test our sign changes. We have one sign change from here to here. We have another sign change. That's 2, 3, and 4. So I could have 4, I could have 2, or I could have 0. Let's go to the negative. If I have f of negative x, 2x to the 4th stays the same, plus 13x cubed, plus 23x squared, plus 52x, plus 60. No sign changes. So that means there are no negative solutions. So when I write out my possibles, I'm going to ignore all the negatives. So if I have 4 positives and no negatives, I would have no imaginaries. If I have 2 positives and no negatives, I'd have 2 imaginaries. Or 0, 0, which means I'd have all 4 imaginaries. So now let's test which ones do we possibly have. So on the top, all of the factors of 60. And again, I don't have to put the plus or minus because they're all positive. So I have 1, 2, 3, 4, 5, 6, not 7, not 8, not 9. Then we have 10, so then we'll go back out. 6 times 10, 5 times 12, 4 times 15, 3 times 20, 2 times 30, and 1 times 60. All over 1 and 2, because they're the factors of 2. So all of my potentials, I would have 1 over 1, which is just 1. I'd have 1 over 2, which is 1/2. I'd have 2 over 1, which is 2. Now 2 over 2 is 1. I already have 1, so I don't have to write those again. So I've done both of these. Then we have 3 over 1, which is 3, and 3 over 2, which is 3/2. 4 over 1 is 4. 4 over 2 is 2, and I already have that. 5 over 1 is 5. 5 over 2 is 5/2. 6 over 1 is 6. 6 over 2 is 3. I already have that. 10 over 2, or 10 over 1 is 10. 10 over 2 is 5. I already have that. 12 over 1 is 12. 12 over 2 is 6. I already have that. 15 over 1 is 15. 15 over 2 is 15/2. I'm going to continue down here. Then we have 20 over 1 is 20. 20 over 2 is 10, and I already have that. 30 over 1 is 30. 30 over 2 is 15, and I already have that. 60 over 1 is 60. 60 over 2 is 30, and I already have that. These are all of our possibles. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 16 possible rational zeros. Now notice, if I have 0 positive and 0 negative, that means none of these are answers. That might happen. It's not going to happen very often, but it might, so be ready for that. Now, what I do is I set up my synthetic division. Okay, this is really step 3. With 2, negative 13, 23, negative 52, and 60. Now I'm going to go through and test the whole numbers first. Don't test the fractions right away. If you go through all the whole numbers and find no answers, then test the fractions. I usually go through and I'm going to test that 1, 2, 3, 4, 5, 6. Okay, we'll start there, and if we don't get it, we'll keep going. Remember that first one comes down. So we're going to have 2 times 1 is 2, plus a negative 13 is a negative 11. Negative 11 plus, or times 1 is negative 11, plus 23 is going to be positive 12. Times 1 is 12, plus a negative 52 is a negative 40. Times 1 is negative 40, plus 60 is going to be positive 20. That one does not work. Let's try the next one. 2 times 2 is 4, plus negative 13 is going to give us a negative 9. Times 2 is negative 18, plus 23 is going to be a positive 5. Times 2 is 10, plus a negative 52 is going to be negative 42. Times 2 is going to be a negative 84, plus 60 is going to be a negative 24. That doesn't work either. 2 times 3 is 6, plus negative 13 is going to give us a negative 7. Negative 7 times 3 is a negative 21, plus 23 is going to give us 2. 2 times 3 is 6, plus negative 52. Excuse me, 6 plus negative 52 is going to give us a negative 46. Times 3 plus 60 is going to be way negative. That's not going to work either. Let's continue on. 2 times 4 is 8, plus negative 13 is a negative 5. Negative 5 times 4 is negative 20, plus 23 is a positive 3. 3 times 4 is 12, plus negative 52 is a negative 40. Negative 40 times 4 is a negative 160, plus 60 is a negative 100. Not going to work. Let's try 5. 2 times 5 is 10, plus negative 13 is a negative 3. Times 5 is a negative 15, plus 23 gives us a positive 8. Times 5 is 40, plus a negative 52 gives us a negative 12. Times 5 is negative 60, plus 60 gives us 0. There's a 5. Now because I have one positive solution, that means I have 2 positive solutions. Because notice I can't have just one, I have to have 2. So x equals 5 is one of them. Now, right now I have a cubic. What I'm going to do, and I'm going to go through and erase some of this other stuff, just to give myself more space to work.
Teachers, varsity girls are dismissed at this time. Thank you.
I'm going to go through and erase some of this stuff just to give myself some room to work. I'm going to leave these up here. Now, I've already tested the 1, the 2, the 3, the 4. 5 worked. Now, I'm going to continue on, but instead of using the quartic that I had, I'm going to go through and rewrite that synthetic division with the cubic that I now found. 2, negative 3, 8, and negative 12. And I'm going to start right where I left off. 6, then we have 10, 12, 15, so on and so forth. Take a moment, at least try the first couple there, to see what you get. To abbreviate the process a little bit, for our sakes, I'm going to tell you now that the 10 and above whole numbers don't work. So let's go ahead back and we're going to test some of the halves. We'll do 1 half, we'll do 3 halves, and we'll do 5 halves. We'll see what happens there. Because I'll tell you now, the 6, the 10, the 12, the 15, the 20, the 30, the 60, those don't work. So it's going to be one of these halves ones, so we'll try those. So we're just going to skip this one. So we have 2 times 1 half is 1, plus negative 3 is negative 2. Negative 2 times 1 half is a negative 1, plus 8 is 7. 7 times 1 half is 7 halves, or 3.5, plus negative 12 is going to be something negative. That doesn't work. 2 times 3 halves is 3, plus negative 3 is 0. 0 times 3 halves is 0, plus 8 is 8. 8 times 3 halves is going to give us 12, plus a negative 12 is going to give us 0. 3 halves is that other positive answer. So then we get x equals 3 halves for our second answer. Now I'm going to get rid of this just to give me room for what I have left. Notice we have this left. We have 2x squared plus 8 is equal to 0. If I solve this, we get 2x squared is equal to negative 8. X squared is equal to negative 4. X is equal to plus or minus 2i. So our 4 answers, plus or minus 2i, 3 halves, and 5. This is the process from start to finish. So take a minute, take a look at that, make sure you have it all down. But that is our process from start to finish. Now I'm going to go ahead and do this one, because it's in the notes and I want you to have it. But I would suggest right now stopping the video and try going through and doing this yourself. Now I know some of you are not going to do that. You're going to listen to me say this, you're going to wait for me, and you're going to just wait for me and copy it down. But it would be a good idea to try it now, and then go through and see what I do, and see, or go until you get stuck, and then see what I do and say, okay, that's what I was forgetting. Because the sooner you can do this stuff on your own, the better off you're going to be. Because this will be some of the toughest stuff we do this year. So if you can do this, you'll be good. So we have x cubed minus 52, or 5x squared minus 22x plus 56. First we're going to go through and discover how many positive, how many negative, and how many imaginaries do we have. So positive. I'm going to rewrite this so it's all in one line down here. We have f of x is equal to x cubed minus 5x squared. I know it should be on one line in your paper, but I want to see it all together here. Okay, so we go from here to here is one sign change, 2 sign changes. So we're either going to have 2 or 0 positives. When I rewrite that, we get negative x cubed minus 5x squared plus 22x plus 56. We only have one sign change here. So that means we're guaranteed to have a negative. So we either have 2 positive, 1 negative, and no imaginary, 0 positive, 1 negative, and 2 imaginary. Okay, so I can get rid of those because I don't need them together anymore. So this is step 1. Step 2, we're going to figure out what are my possible zeros. What can I choose from? So we're looking here. We have the factors of 56. Now I have both, so I have to write both. Plus or minus 1, plus or minus 2, not 3, plus or minus 4, plus or minus, not 5, not 6, then we have 7, 8, and then we're going back the other direction. So then we have plus or minus 14, then we have plus or minus 28, and your plus or minus 56. All over plus or minus 1, so really there are no fractions this time, which is nice. We just have those numbers. So I'm not going to rewrite all of them. If it's over 1, you don't have to rewrite them. It's just plus or minus 1, 2, 4, 7, 8, 14, 28, 56, which is nice. Now this time, here's a different strategy for you. So now we're on to step 3, synthetic division. So I'm going to jot this down. We have 1, negative 5, negative 22, and 56. Now, I'm not going to go through positives. I may have no positive solutions. I'm guaranteed to have one negative. So I'm going to go through and write my negatives this time until I find it. And that way I'm guaranteed to find my solution this time. And then I can go through and factor the quadratic or quadratic formula or whatever that may be. So again, these all come straight down. I'm not going to write all of them. 1 times negative 1 is negative 1, plus negative 5 is negative 6. Negative 6 times negative 1 is a positive 6, times negative 22, or plus negative 22, is going to give us a negative 16, times negative 1, plus this is going to give us 72. So that one doesn't work. 1 times negative 2 is negative 2, plus negative 5 is negative 7, times negative 2 is 14, plus the negative 22 is going to give us a positive, or excuse me, negative 8, times negative 2 is going to be 16, plus 56 is going to, again, give us that 72. That doesn't work. 1 times negative 4 is going to be negative 4, plus negative 5 is negative 9. Negative 9 times negative 4 is a positive 36, plus a negative 22 is going to give us a positive 14. 14 times negative 4 is going to give us a negative 56, plus 56 will give us 0. So my one negative solution is x equals negative 4. That's my one guaranteed real rational root. So now I can get rid of the rest of this because that doesn't matter to me anymore, because I found it. So there are no more negatives. So now I'm going to use, so we have x squared minus 9x plus 14 is equal to 0. And I'm going to ask myself, can I factor this? We can. It can go into x minus 7, x minus 2 is equal to 0. So I get x minus 7 equals 0, so x equals a positive 7. X minus 2 equals 0, so x equals 2. So I actually ended up with 2 positives, 1 negative, and no imaginaries. So 7, 2, and negative 4 are our real rational zeros. Again, make sure you have those things copied down. Make sure you have all that information. Make sure the process starts with how many positives, how many negatives, how many imaginaries. Find the P over Q. Do synthetic division. And then after the synthetic division, you're either factoring, quadratic formula, whatever you may need to do to solve that completely. Your homework, 372, 10 to 24 even. Make sure you have this note sheet handy. Because having this process handy is going to be really, really helpful in seeing, okay, once I do this, what do I do next? And kind of guiding you through that whole process. Because again, I want you guys trying these before you ask me questions. So don't just say, oh my goodness, I have no idea what to do. Look at the notes, analyze the notes, and figure out what am I supposed to do. So that is the homework, 10 through 24, the evens. And you'll want to we'll be working on that tomorrow together in class.